You can see on the left, we have a moving texture, which is the texture atlas. And then on the right, we have our area in which we can work in and paste tiles. Like for example, I could take this tree here, make a box selection. I can switch between the layers and maybe paste the tree right over here. While developing my game, I came across the problem that I needed some more functionality than what the tile editor I had been using before gave me. For example, I needed to tell the tile system which of the tiles can be used as a road or as grass. And so you can see the slightly greenish color and the slightly reddish color, indicating that this is a path. So I needed some more functionality. And as well, I wanted to test if writing my own tool was a good decision or not. For anyone that doesn't know, I'm building a game called Cakez TD, which is a tower defense game. It's inspired by balloons, meaning that you can always see the entire level and there's no scrolling to the left or to the right. So in order to build these levels, I need to place tiles properly. And so I'm building these levels in my tile editor. And at the very beginning, I had been using tiled. The reason why I switched was the realization that tiled gives me predefined options to export the created level, for example, as an XML file or CSV file. And so many of these files actually didn't help me at all. Like for example, the CSV file would give me a bunch of numbers. So basically the import routine that I came up with was, okay, I need to read in these tiles, these strings, convert them to integer values, convert the 90 to an integer because it's a string, and then turn that into a tile in my game. Back then I didn't want to do that, so I came up with my own tile editor. So at the very basis, a tile editor just consists of a bunch of layers that are divided into tiles. And every single tile tells you what it's referencing. In my C++ program, I treat a tile atlas as a texture with coordinates. So 1 vector 2 in integer vector 2 gives me the coordinates into a texture. For example, for my game, I have this ginormous texture atlas here. And to the left, you can see there is a bunch of tiles together. And so, for example, if I wanted to reference this top left tile, I would have to supply, you can see that at the bottom left here, the position 0 and 160. And so the very first thing I created when creating the tile editor was the tiles array. It is a 2-dimensional array with a fixed width and a fixed height. I decided, after looking at balloons and inspecting Stardew Valley, because I thought it was a cool game, that a size of 480 by 272, which is a good size that is usable for 16 by 9 screens. So you have a 30 tile width and 18 tiles height. So I created a tile array that exactly fits that size. If you have other needs, maybe you use a vector here or maybe a bigger array, that's up to you. And this is one tile layer, and one tile layer can either be visible and can have an opacity, in my case. And what is a game background then? What is a background that you create? In my case, it's just a bunch of these tile layers together in an array. That's basically the layering feature of tiled. Then I have a bunch of other data that is specific to my game and not specific to a tile editor. I need to know the type of background that I'm editing and the texture atlas. Those two things are not very important, so I'll skip over them. Also, these background paths. This is just specific to my game and not specific to anything else. If you were to create a tile editor yourself, you probably would make a naming routine that says, oh, how do you want to call this background? Fine, save. Something like that. Okay, so then in the actual tile editor, we have the game background that we are working with, the one that I showed you before. And all of the other options make sense if we go through what a tilenet editor actually needs in order to work. And so it makes sense to look at the visuals first. You can see on the left, we have a moving texture, which is the texture atlas. And then on the right, we have our area in which we can work in and paste tiles. Like for example, I could take this tree here, make a box selection. I could switch between the layers and maybe paste the tree right over here. In short, we have this selection area and we have this working area. Those two areas are being defined in the update loop of the tile editor. Over here we have the texture box, hard-coded with sizes. And we have the background, also hard-coded with sizes. And so these are two boxes, you can think of them, like two rectangles. What happens is, for example, in this texture box, I'm referencing where I'm clicking with my mouse. I'm saving where I'm clicking with my mouse. And I need to know where in the texture atlas did I click my mouse at. So I know that this is the index into a 16 by 16 grid. So I need to be able to, if you can see, this is separated into a 16 by 16 grid. If I click on this white circle here, I need to know that this is grid index X 0, 1, 2, 3, 4, and grid index Y 0, 1, 2, 3, 4, 5, 6, 7, 8. That's the basic thing. That's the number one thing that you need to find out when you're using or you're trying to copy tiles from an atlas into a tile layer. And so I created a function called getGridIndices that takes in a grid position and a grid size. That would take in the top left anchor point of this and then the entire size of the texture, which expands further to the right. I also need to take in the mouse position, the tile size, which is 16 in my case, and how much I'm scaling the tiles by. And there's a little comment that says this function assumes that the grid size is perfectly dividable by the tile size, meaning that if I have this grid over here, I can scale using my mouse wheel. And as you can see, it increments in chunks. What is happening is I'm scaling by 1, 2, 3, and 4, which makes it much easier for me to determine where the mouse actually is inside a grid. And so the first thing I do is to take the tile size and scale it by the scale, which gives me, let's say if I scale it by 2, a size of 32 by 32. And then I take the grid size and multiply that by the scale 2. And then I do some basic math. I take the mouse position, remove the grid position. Now I'm relative to the grid. And then I try to make sure that I'm never clicking outside of the grid by clamping it between 0 and the grid size. And I noticed that earlier, I don't need a floor here. I'm just taking the mouse position and dividing it by the tile size. That's the number one thing that I'm doing here. And I'm also doing that, as you noticed, if I press the G key, I can turn on the grid. I'm doing that here too. The relative position top left is over here. And then if I click on anything inside this grid, I can copy the tiles that are inside of that layer and then paste them somewhere else. So that's the number one thing. And again, the floor is not needed, but turning that into an int is needed, which basically is the same thing as flooring down. Now that we can get the grid indices, it is time to look at what happens when we actually make a selection. So let's assume we click in the left box inside the texture atlas. We have just clicked the left mouse and we are inside this texture box. Then I'm storing the texture coordinates in what I call a texture coordinates start. I'm getting the grid indices of my click, right? Which would be on Y, it's very simple. It's the index 1. And then on X, I don't know, we have to count 1, 2, 3, 4, 5, 6, 7, 8. So that would be 7 because I started at 1, right? 7 or 8. And then I turn these indices into texture coordinates saying that, okay, well, we have 7 times the tile size of 16 and 1 time the tile size of 16. So that would be 112 coordinate on X and 16 on Y. I'm storing these texture coordinates and I'm saving them in my tile editor. And the same thing happens when I release the mouse. I store the texture coordinates end. Then I do a bunch of swaps to make sure that the start is always the minimum of the texture coordinates and the end is always the maximum. Makes it easier to work with later. And then the next interesting thing is, how do I draw my selection that I have just made? Let's assume I'm making a box selection on this tree here. Part of this tree. Now, how do I draw this selection? Since I've just stored the texture coordinates, and don't mind the paste from background, we'll get to that later. Down here is what we are interested in. So we create 2 loops here. And both of those loops store the beginning of the texture coordinates, which would be like our 112 and 16. And every time they increment each other, they increment by the tile size. I know that this is a very confusing loop and it would be much easier to just work with indices instead of actual texture coordinates. And it would allow me to basically get rid of a bunch of stuff here, but I haven't. And it's working, and so I don't care. If you plan on making a tile editor yourself, don't work with texture coordinates, but work with indices, okay? I don't know if I'll ever change it. It works and I'm happy. So yeah, basically we increment the texture coordinates by the tile size every time we draw a tile. And how does that work? Well, how do we know where to draw the tiles? We do the same thing with this background as we do with the texture coordinates. Every time we move our mouse, on basically everywhere the mouse is, we get the grid index into this grid, and therefore we know where to start pasting these tiles. And so over here, it starts drawing the selection down from the top left position of my mouse. And so for every single quad that we draw it with the offset into the atlas and the size of the tiles. Tile size over here. The texture size is the tile size, and the coordinates are basically the texture coordinates that are being calculated by those two for loops. And every time we draw a tile, we increment by the tile size. Which, you know, is terrible. I'm not gonna lie. Now that is number one, how we can paste tiles. We could also paste tiles by making a selection in our tile editor background. Basically, I make a selection over here, and I'm pasting this tree. And I'm now pasting from the background. And that's the easier part that I did after this, which can be found in the draw background code here. First, I'm checking if I'm doing a right mouse click. I thought that I do it the same way as in tiled, and therefore, if you do right click in your tile editor, you can select tiles. And so we click the right mouse button, we store the grid indices into the background grid, and then we store them in the editor as background grid indices start. And this is where everything made click for me. Actually, I don't need the texture coordinates. I just need indices. So we store the background grid indices start, and then when we release the mouse, we store the background grid indices end. And we do the same minimum, maximum shenanigans. Then last thing that I haven't talked about is how do I know where I'm pasting my tiles from? And for that, I created options, which is basically an enum bits in this case. So we have the option to show a grid, which is bit 0, and then we have the option to paste from the background, and then we also have the option to paste from the atlas. Now, obviously, we could concatenate these bits together and then paste from both, which would be terrible. But I didn't want to create a bunch of boolean saying paste from background, paste from atlas. So basically, if I make a selection here in my background, I'm saying, okay, I'm pasting from the background, and please, I'm not pasting from the atlas, which is very unsafe, but it works. Yeah, and then I do the same crappy shit with the texture coordinates. I'm actually getting the texture coordinates from the background, and I'm storing them in an array, which is the copied texture coordinates over here, which I will be using to paste from the same way I used the texture atlas and the texture coordinates in my other selection. Okay, so now we can make a selection and paste that, and we can make another selection and paste that too. How do we actually draw this background? And if you guessed it's just a for loop, inside a for loop, inside a for loop, then you will be right. And that is this lovely code right here. In my case, I have a maximum tile layer count. I didn't want to deal with any dynamic layering and stuff. I don't like dynamic memory allocation. Someone that's watching me on YouTube or on Twitch knows that. So I'm just iterating over all the layers, check if they are visible or not, continue if they are not. And then I go over the rows and columns. And guess what? I'm just getting the texture coordinates out of the tiles. I skip if they are not visible. Or if I don't have any texture coordinates, basically 0, 0 does not need to be drawn. I get the tile position, basically editor position plus column row index times tile size times scale. Boom. Right, I'm scaling this, anyone that's wondering, since I have 16 by 16 tiles and a size of 480 by 272 in total. This is bigger because I'm scaling it by 3. I made the math and this fits over here, and then I have enough space, in my opinion, on the left for my 1080p monitor to display me enough of this texture to work with. Yeah, and then I just draw the quad. Boom. Now, another important thing that you might be interested in is how I save and load my backgrounds. Essentially, I'm just taking the entire game background pointer or memory, and I'm saving that to a file. For anyone that doesn't know what it means, I can go ahead in my game and then open one of these background files, like for example, the Endless Assault. This is basically a bunch of data clamped together, right? A bunch of nulls, because there's not much in there, and then some data that needs to be interpreted the right way. And so currently I'm using about 64 kilobytes for each background. Not sure if that is a lot or not. So I'm just saving this as a binary dump to the disk, which can be annoying if you change your background structure, right? I'm essentially just pasting what I have in here. And if I were to, which is why I have these background version old and background version, you can see that in the new version I added the placement grid over here. And so when I load a background, now there's a bunch of stuff missing, and I need to make sure that the data, if it's not present in the current file, needs to be set to something, which is like an eternal problem of save games. And whenever I solve that problem myself, I'll make a YouTube video about it, because it's not that trivial to do. I'm pretty sure it's solved in many cases, but for me, I'm still learning this. So basically this is saving the background, and then over here at the bottom we have loading background, which does a little bit of file version checking, and then it checks, oh, do I have the correct file version? And then I'm checking if the size is the same. If not, then I basically do a bunch of handmade coding. And this code always changes as I'm developing, because the last time I was using this to copy over the tile layers. Next time I might be using this to do something else. But in my opinion, that has nothing to do with a tile editor per se, but more so a saving and loading routine of files and versions. You know, creating header files and then looking at the data. What type of version do you have? What is inside that? And so on and so forth. I hope I didn't miss anything, because that's mostly all you have to do in a tile editor. You need to know where in the grid or the texture atlas you are referencing your textures or you're making your selection. You need to know whether you are pasting from your texture atlas or you're pasting from your background. Then you need to know how to draw that selection. Then, yeah, you need to replace the tiles on pasting. And then lastly, you could want to draw a grid, which is basically every 16 pixels you draw a very tiny quad in white that is as long as your grid is, right? And so I'm drawing this line at the bottom, I'm drawing this line to the very right, and then I go over and I keep drawing these lines. And yeah, that is it. That is how I'm generating my backgrounds for my game, Cakez TD. Now we come to the actual conclusion. Does it make sense to make one or not? It always depends, I would say. In my case, currently it makes sense, because I basically have all control. Like if something is pissing me off, I can fix it. If a feature is missing, I can add it. Right, that's the power of C++. Anything I want to add to this, like for example the placement types, boom, I can implement. Easy. Now a game background also stores the tiles that I can actually walk on, or that enemies can walk on, or that my units can be placed on, right? Background type, placement type, water. I'm only interested in water tiles, and I'm turning these into water tiles. Or maybe actually this is a pond, and I can place maybe water units in the future that I don't have yet. But the downside is, the biggest downside, modding. How do I make modding possible? I can give players access to this, and then they can open the tile editor, they can see the texture over here, but they won't be able to edit this texture. The texture is baked into the asset system right now. And even if they could, they are limited to this tile editor, which again might be a good thing. And so we'll have to see in the future whether I change my stance on using the tile editor, tiled, this one right here, or not. If I can make it entirely in my engine and every single software piece that I'm using is owned by me and I have full control over it, I think it's worth a try. And I'll try that before I go back. So yeah, that concludes the how I made a tile editor and how to make a tile editor. If I missed something or you don't understand something, feel free to hit me up on Discord. You can find the link in the description, or on my stream, Cakez77 on Twitch, or in the comments if you have any questions. And also, if you don't mind, tell me if you like this type of devlog. I have no idea. I've tried to make funny devlogs. I'm not actually funny. I try to make informative devlogs now because I'm tired of looking like a dumbass. Hopefully now I look a little bit smarter than before. Because, not gonna lie, I learn a shit ton making my game in C++, and in my opinion it's an invaluable experience. Anyways, hope you enjoyed the video. If you did, leave a like. Give me all the likes, please. I need more likes. More likes equals better person, okay? Please. See you next time. Peace. If you like what I do, consider tuning into my Twitch. I stream at 10 AM Central Eastern Time, which is 1 AM Pacific Daytime. I also want to thank all my Patreons for supporting me on this journey. Silly, Daniel Scorbo, Techbox North, Shrubdor, Michael Phillips, Felix F, and Meo Meo the Writer. Thank you very much. As a thank you of mine, Patreons get access to the source code of the game, and occasionally I post pixel art that can be used for free.